Hello, this is Mr. Collier, and today we're doing some real-life examples of linear equations. Okay, so if we look at the formula, the slope-intercept formula for the equation of a line, it's y equals mx plus b. And remember, the m stands for the slope, okay, and b stands for the y-intercept, okay? Alright, now in a real-life context, well, in the graph of a line, the slope is changing each time. It's the amount that the y value changes each time when you go from point to point. In the real life context, that's going to be your rate of change. Okay, so in the real life context, the rate of change will correspond to the slope of the graph. It's going to be the coefficient of x, or whatever the variable is going to be. The y-intercept in the real-life context might not always have a meaning in the real-life context, but if it does, it's going to be the initial value, or maybe the starting point, okay? Or it's going to be the constant part, or something like that, okay? It's not going to change. It's going to be an initial value or starting point or a constant part, and the rate of change is, of course, going to be the one that's changing in the situation. So let's take a look at some examples. Okay, like in this example, cab company charges $3 boarding fee in addition to its meter, which is $2 for every kilometer. So we're going to have like an equation in the form y equals mx plus b, okay, where we have a slope and a y-intercept. So we need to look here and figure out what the slope and the y-intercept is going to be. Well, in the real-life context, the rate of change is going to be the slope. So which one's the rate of change here? We've got to figure that out. The one that's changing here is the 2 kilometers for every hour. That's a rate, okay? And then this one here is constant. Okay, that one's constant, the $3 fee. This one here is a rate. It's changing depending on how many kilometers it is. So your equation is going to be of the form y equals $2 for every kilometer plus the initial amount, which is $3. Okay? Now, rather than writing y and x, in this case, we have, in a real-life context, we can change the symbol if we want. We can write this as cost equals $2 per kilometer. So let's put distance in here, 2d plus 3. So we can write cost equals twice the distance plus 3. Okay, now we're gonna be graphing. Okay, now in a real-life context, you often don't need negative numbers, and we don't need negative numbers in this case. So we don't need a graph with all 4 quadrants. We can just graph in the first quadrant where everything's going to be positive. Okay, so on this graph, first of all, we can label the x and the y axes. The x-axis down here is going to be our x corresponds to d, which is distance. So that's going to be distance in meters. Okay, and on the side here, we're going to have cost in dollars. Okay. All right, and okay, so it's going to start at 3. The y-intercept here is going to be 3. So let's put in the y-intercept of 3. Our slope is 2, so for every kilometer we're going to go up 2. So we're going to go, and you can write this slope as 2 out of 1. So the rise is 2, the run is 1. It's going to look like that. Rise 2, run 1, rise 2, run 1. Okay, so we can keep doing that. We can fill in all of these points. Okay, and let's connect the dots. And there we go. We have the equation, or we have the line representing this relationship. Okay, so it's a positive slope because the price is always increasing, and it's a starting value of $3 down there. So that's how you graph it, and there's a couple follow-up questions here. Now remember, our equation is cost equals twice the distance plus $3. So how much would it cost to, how much money would a 27-kilometer ride be? So we can use our formula. Okay, this corresponds to the distance. So if we use our formula, cost equals 2d plus 3. So the cost is going to be 2 times 27 plus 3. So the cost is 54 plus 3, which equals $57. So that taxi ride will cost $57. In the second question, Lars spent $75 on a taxi ride. This corresponds to the cost. So in our formula, cost equals 2d plus 3. We're going to substitute the value of 75 for the cost, and then solve for the distance. So we're going to subtract 3 from both sides, and we get 72 equals 2d. Divide by 2, and we get the distance equals 36 kilometers. So that taxi ride was 36 kilometers. Okay, one more example. Okay, in this example, Deborah has to pay a $10 flat rate and 5 cents per minute. Okay, so flat rate, that's a constant amount. Okay, and this here is a rate. It's per minute, it's a rate. So that's going to be, the rate's going to be your slope, and the constant is going to be your y-intercept. So we're going to have y equals, slope is 0.05, and the y-intercept is 10 euros. Okay, now, so that's your equation. That way we can write it in this real-life context. We can write maybe cost equals 0.05 times the number of minutes plus 10. So we can write it like that. Again, we don't need the negative axes, so we're going to set up our graph like this. Okay, we're just the first quadrant where everything's positive. Alright, let's label the axes. This down here is going to be number of minutes. And the y-axis here is going to be cost, and this is actually euros. Alright, now we're going to have to mess around with the scale here a bit. We can have number of minutes down here go up by 1, I guess. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, so that's 10. 1, 2, 3, 4, 5, 15. 1, 2, 3, 4, 5, 20. 1, 2, 3, 4, 5, 25. But over here, we have a very small slope, and we're going to start off at 10. So if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I make a point here, then each time we're going to go up 5 cents. It's going to be next to impossible. So what I'm going to do is I'm going to make a break here in the graph, and I'm going to start off at 10 down here. Okay? So I'm going to start off at $10. It's going to go up by 5 cents each time. So why don't I go up by 5 cents each time? This is going to be 10.05, 10.10, 10.20, 10. Let's call this. So we go up 5. 1, 2, 3, 4, 5. Okay, and that's going to be 10.25. 1, 2, 3, 4, 5. That's going to be 10.50. 1, 2, 3, 4, 5. That's going to be 10.75. Okay, something like that. So let's plot the graph now. The equation is 0.5 m plus 10, so the y-intercept is 10. For each one, I'm going up 0.05. So I've set it up here so it's going to look like this. Each one we're going up 0.05. So it looks almost like a slope of 1, but remember the units here on the side. This is actually going up 0.05 each time. So if the scales were equal on the x and y axis, you would have almost a horizontal line here. It would be going up very slightly. But it looks like this. Okay, we're going up 0.05 each time, because that's the slope. And let's draw a line here. Okay, so here we go. Here is our line. Draw an arrow on the end to indicate it keeps going forever in that direction. And there's our line. Okay, now there's a couple follow-up questions. Remember our equation is cost equals 0.05 times the number of minutes plus 10. Okay, so how much will her phone bill be if she talks for 168 minutes? So let's use our equation. Cost equals 0.05 times number of minutes plus 10. Cost equals 0.05 times 168 plus 10. So the cost equals, if I work that out, it's going to be 0.05 times 168 is going to be 8.4 plus 10. So the cost equals 1840. Okay, so that's going to be, this was in euros, so it's going to be 18 euros and 40 cents. Okay, the second question. Now this should be 2740. Just a second now. Do I have those numbers mixed up? Yeah, this should be 2740 on the phone bill. Sorry about that. Okay, so let's take a look at the cost. Cost equals 0.05 plus m plus 10. So in this case, we've got the cost of the phone bill, so we put that in here for C. So we're going to have 2740 equals 0.05 times the number of minutes plus 10. Okay, then we're going to subtract 10 from both sides to solve the equation. 1740 equals 0.05 m. Then we're going to divide both sides by 0.05. And we're going to have m equals, so let me work that out. That's going to be 348. So the answer is 348 minutes. Okay.